Okay, in a previous lecture, we are doing digital image fundamentals, and these are the some important topics that we have to cover in chapter 2, digital image fundamentals. And just go through the some previous slides, and then we will go towards the uh, half uh, second half of the second chapter. And yes, in our previous we have one, two, yes, in our previous lecture we have done elements of the visual perception, which includes have understand the there are the actually the eye images or surface of the eye is made up of the two receptors that is called cones and rods, and there are millions of and roads are available. And there is a one important topic that we have covered under this topic that is called the blind spot. So the blind spot is one of the most important point uh, uh, where no cones and rods are existing. So the next topic is the image formation in the eye and how the this 15-meter image is imaged by our retina. So it is in actually reverse position, and that is around uh, to there is a 25 mm. So that is actual height. How we have calculated? There is a simple formula is there, and you can very easily calculate. And this is a difference between actual intensity and the perceived intensity by our eye. There is in this figure we have learned about the how the background actually affects the um, there is an inner portion of the image, and here you can just see it as a there is a one, there is a first figure is there is a second figure is there, and the third figure is there. And in all the figures, the center, there is a center, this center portion is of gray color, and that is same for all three figures. And it is same for all the figures, this pattern. And once we have changed the outer part, the center portion become or look like darker in figure 3 as compared to the in figure 1. So there is another part that is optical illusions, and the optical illusions are look like that, and how we can perceive these are just a lines which are at a different angles. But here it look like as a there is a some circle is there and some outer circle is there. So they are representing the two types of the circle, and there is a figure 1 there is a, scare box is there, and but in actual there are only these two sorry these four dark, there is a you can say it as a there is a four dark symbols are there, and which actually represents the nothing but our eye perceived it as a there is a square in between these four circles. So there is another illusion is a pattern. There is a in figure D, there is a pattern is there, and there is a electromagnetic spectrum in which gamma rays, X-ray, ultraviolet, visible, infrared, microwave, and radio waves are existing. But our eye can can acquire the information through a visible band only. And the visible band, when we are talking about the visible band, we are actually talking about the blue band, green band, and the red band. And these yellow, orange, these two colors are falling between the green and red. we always say that the red, green, and blue. These three bands are like an three seeds. And there is a relationship between the wavelength and the frequency. So that is a very general formula, and we don't need to go into in details. Yes, and then we have covered the image sensing and the acquisition process, and there is a filter is there which removes the undesirable noise, and then the sensing material is there which converts the input energy into the voltage waveform, and it can be one of the two. It can be acquired by the line sensor, that is as shown in figure A. This one is a figure A, and or as uh, another way, that is called the array sensor as shown in figure P. So hopefully you will get this point. There are two types of line and array is there, and this one is a scanning mechanism through a line array. And yeah, the sensor is embedded on this, and this sensor is rotating from that is in x-axis direction, and this rotation, that is a drum, is rotating on a y-axis. And there is another some other some other sensors are there to acquire the image. There is a linear strip sensor is there. There is a strip is there. Then it imaged all the area, and there is another circular sensor strip is there, which was generally used in the for X-ray scanning. And here there is a X-ray source is there. This one is a X-ray source, and this is a 3D object. And the inner part of the wing, which is act as a sensor to sense the imaged area. So the another one is that is how we can convert or how we can convert and how it is converted into the digitized form. So in this process, we are using the sensor array, and this one is a this one is a sensor array which image the array, which image uh, the actual object in the form of arrays of x-axis and the y-axis. So this one is a x-axis and y-axis, uh, and it actually acquires the reflections from the object, which is in the uh, there is a analog and digital form. This one is a figure A, which is representing the actual image sensed by the sensor. How we can convert image into the digitized form. There is a actual image is in analog form. We can say that, and then we have to convert this image into the digitized form. Okay, sorry for interruption. Am I audible? Okay, yes. Okay, here we will continue from this slide. Yes, there is a simpler difference between the analog and the digitized form. And this is a representation of the digital images that is in form of the there is M and N. There is N rows and N columns, and here the F is actually representing the intensity level of that particular image. And in this image, uh, there is around yeah, 8 different gray levels are using, which having a range of from 0 to 7, and which is actually representing the octal image. And this is a 3D surface of or a 3D image of that particular 3D intensity image. So the figure A is actually a 3D intensity image of a figure B. So this one is a figure B of a figure B, and here you can just check it out here. There is a zeros. Zeros are actually representing the black portion. Point 0.5 is representing the gray portion, and this one is white is actually representing the white portion. So the white is represented by 1, and the gray level is represented by 0.5. So with respect to that, we are the actually this uh, intensity level, that is fxy. Fxy is representing intensity level. This one is a 1, and this one is a 0. So this the intensity diagram of this image is look like that. So this is only just a representation, and at last we have ended up the session with this slide. And in which I have just added this equation so that you can recognize what is the M and K. Please note that the M and N is nothing uh, but that is M into N. That is image is formed in form of the M into N. There is a M columns into row. So the image, if you want to calculate the bits required to store a digital image, then it can be calculated by multiplying the uh, rows and columns, and multiply with the k. K is nothing but just a number of gray levels used within that image. And here, if the both rows and columns are equal, which is normally both are equal, and your end result will be look like that. There is a n square k. So this is a graph in between there is a n, which is actually representing the rows. There is a number of pixels are there, and this is a storage capacity required. And why it is divided divide it, because we are calculating it. If you are calculating in the form of bits, then you no need to divide it. And this 1 to 8 is actually representing the gray level. And for example, if I am taking the k, that is, let us do if 8. So this is a we are talking about this value. If if it is a 8-bit image, then 2 raised to power k is equal to 2 raised to power k 8 is equal to 256 different levels of the gray, and which is for, having a range of from 0 to 255, and then then this k is multiplied with the number of rows and columns. So if both are equal, then you can consider it as a square and multiply with the number of the gray level image. And at the end, we can calculate how much data is required to store a particular image. So the now the next topic fall under the digital image fundamental. There is a step of reducing the spatial resolution of a image. So what is actually spatial resolution means? Spatial resolution, here we have checked, we have explained referred to as a dot per inch. So there is a first image which is very clear to you. Uh, it is acquired at 930. There is a 930 dpi. There is a maximum very highest dpi. There is a 930, and your next image is calculated. Sorry, visualized as a at a 300 dpi. Your C figure is represented as a 150 dpi, and your last figure is represented as a 72 dpi. And please note that in a first, as compared to the first image, there is a original image. The size of a 2136 into the 2140. This is nothing but representing the rows and columns. There is a number of pixels fall under the DPI of an image from 930 to 72, and it is an array of only 165 into 156 pixels. So you can also compare this resolution with the help of a DPI, but you can also do it assuming it as uh, with the at a 930 dpi, the image is very clear, but the quality of our image is decreasing as the dpi is is decreasing. And with respect to or with respect to same, there is a spatial resolution. This one is there is a number of pixels are also reduced. So here the role of spatial resolution in improving the figure, improving the image of a particular object. And this one is a yes, yeah. Here you can very easily, if it is clear to you, then note that the figure A is actually acquired data. There is 8-bit. There is a 8-bit image, and this one is a 7-bit image. This one is a 6-bit image, and this one is a 5-bit image. So you can easily calculate the number of gray levels from this value of k, and in this figure the number of there is a number of intensity levels are. There is 2 raised to power 8, which is equal to 256. So there are 256 gray level existing in that particular image. There is a figure A, and in the last figure there are 5 bits are only there, and so 2 raised to power 5 is equal to 32. So there are 32 gray levels are there, and this may not be clear to you because we are visualizing online, but please note that the clarity of a 8-bit image is higher as compared to the clarity of a 5-bit image. They have further reduced. So there is a in the previous we are talking about the 8765, and this one is a 4-bit image, and this one is a 3-bit image, and this one is a 2-bit image. And in the 1-bit image there are 2 raised to power 1, which is equal to 2. So there are only 2 levels are there, black and white. So it is very hard to recognize the parts of the skeleton, and or some different features of the this from this image, and we can easily recognize from the there is a 8-bit image, but it is very difficult to recognize from the there is a 1-bit image, 2-bit image, and a 3-bit. Definitely these are not sufficient. 1, 2, and 3 bits are not sufficient. But yes, the fourth one is little bit effective as compared to the 3-bit, 1-bit, and 2-bit, and the 8-bit is far better as compared to the 7, 5, and 6-bit image. So hopefully you can recognize that what is the difference between these gray levels and how it can improve the. So in our next here we are talking about the image with the Yeah, there are three images have been acquired, and the first image with the low level of the details, and in this case, and then this the second image is required with a medium level of the details because there are medium level of details are required, and this is the maximum large amount of the details are required because there is no any information in the background. So we need a very low levels of information, and yes, there is a background is there, but very not a background. So that requires the medium level of details or provides the medium level of information. And the figure C, yes, here you can see that there is a too much crowd is there, which need a large amount of the details. Uh, so the representation of the ISO, there is a preference curve for these three types of the images, and this one is look like. And first, you noted that this has been designed with respect to these two parameters. That is the N and K that we are talking about the previously. There are two parameters are K is there, and please note that. And okay, this line is representing for the crowd. This one is a C for figure C, and this line is actually representing for the cameraman, that is which is B, and here there is a first line is represented for the figure A. The figure A is just representing the face, and there is a cameraman is there, and the third one is crowd is there. So this is a that is a intensity as well as the number of levels are um, varying with respect to these two parameters of these three images. And please note that shift in a up and right, this one is up and right in the curve simply means that the larger values for the N and K. Please, if it is increasing towards the upper side or a right hand side, then definitely if it is increasing towards the right, then it is uh, increasing the N, that is the N value, and if it is increasing upward, then it will increase in the K value, and which definitely implies the better picture quality. So hopefully you will get this point. There is just a representation of these three figures. And then now the next important topic in our digital image processing, that is image interpolation. Yes, interpolation is used in task to zoom, shrink, rotate, and geometrically correct the digital images. And the basic principle involved in resizing, that is which involves the shrinking and the zooming, that is based on the resampling method. And for example, there is an example is there in which and the image that is represented by the 500 by 500 pixels needs to be uh, enlarged 1.5 times. So that is called upscaling. That is a or we are converting from the 500 to 500 pixels to 750 pixels, 750 into 750 pixels, and this can be achieved by the three basic methods with the help of the three basic methods. That is the first one is a nearest neighbor interpolation, and the second one is a there, and the third one is a bicubic method is there. So now, what is in nearest neighbor that we will do it in upcoming slides. Let me check if there is. Yeah, that we will cover in upcoming slides. There is a four nearest neighbor points they will use. For example, in a figure, there are 9 pixels are there, and we have to calculate the uh, we have to average that particular pixel, then we need to use the four nearest neighbor pixels. So, for example, we have to identify the value of that particular pixel. This one is the x, and the nearest pixels are there are these four nearest pixels are there, that is in vertical and horizontal position. And definitely, if all are one, then we can assign it as a one. There is a little bit of different phenomenon, but yes, that is related to the nearest neighbor. And we can also consider it on a diagonal sides. That is, for example, one is there, one is there. Neighbor, there are two methods are there. That is a vertical horizontal, and the second one is a diagonal. You can consider the diagonal nearest neighbor pixel to to estimate that to estimate the intensity of a given pixel, or you can use the diagonal nearest neighbor pixel. So the another one is a bilinear interpolation is there. In a bilinear interpolation, there are four coefficients which can be determined from the four equations for the four unknown values, these four coefficients. There is a 1, 2, 3, and 4, and uh, that can be written using the four nearest neighbor points. So we will you no need to worry about it, and we will do all these three methods in details in our upcoming lecture. And in this case, you have to remember this point, that is the interpolation is used to use for these four operations, and three methods are available for the interpolation. That is, the first one is the nearest neighbor, second one is a bilinear, and third one is a bicubic. So here is example how we are in this case, that is the image is reduced to the that is 72 dpi, then zoomed back to its original original dpi, that is a 930 dpi, using the nearest neighbor interpolation. And okay, you can check it out here. There is a once you have decreased the dpi, then it is possible to come at actual position, that is a 930 dpi. And this image, that is in this image, there is a 72. Uh, there is actual image is converted into the 72 dpi, and 72 dpi is zoomed back to its original position, that is a 390, and here it look like as a what is a figure 8. And the second figure B, the image is reduced to the 72 dpi and zoomed back using the bilinear interpolation. So there is another method of interpolation, and there is a third method is there. There is a bicubic interpolation is there. So now you can estimate which one is better, and as compared to the images or output images, we can estimate, as in this example, that the bicubic is performing well as compared to the there is a nearest neighbor. There is a this one is a nearest neighbor and the bilinear. So the both are not much successful as compared to the bicubic to recover that particular image. Okay, this is a neighbors of a pixel. That is just nothing but just representing the basic relationship between the pixels, and this is representing the yeah, that is representing the coordinates. In this case, for example, there is a 3 by 3 images here. There is a 3 rows and 3 columns, and in the first case, there is a x plus 1. These are basically coordinates for this point, for this point, and this point. So they are representing the coordinates of these 4 points. you just I can expect that you can just easily understand this point. And in another, there is a four diagonal neighbors. In this figure, we can take it as a same example, and they are talking about there is this diagonal point, which is actually representing the this, and okay, right here. Okay, this point. Okay, not actually this point. I just have to write it very clearly. Okay, assume it as a this one is a A, this one is a B, this one is a C, and this one is a D. So this is a zero. You can assume it here that is a zero. Now, in this case, if we have to assume it for this point, there is definitely minus x minus 1, as well as the y minus 1. So the d is actually existing over here, that is representing the coordinates x minus 1 and uh, y minus 1. And here we are talking about this one is the a, where the x is uh, adding and the y is also adding. And this one is represented as a in which the x is adding but the y is subtracting, that is a b, and this one is a c. So hopefully you can get the location of these four variables, that is a, b, c, and d. And similarly you can also do it for these four pixels which are existing over this at that four particular points. So there are two types of nearest neighbors of the pixel, at a diagonal location or a horizontal or vertical location. And hopefully you are able to get this point. And there are some another terms which are related to the digital image, that is adjacency, connectivity, regions, and the boundaries. And in the first case, there is a four adjacent, and let us do it with the help of an example. That is in the first case, there is a some three pixel images there, and one is representing the white pixels, and black is represented by the zero. And here you can just yeah, the figure A is actually representing the arrangement of pixels. Now the figure B is actually representing the, there is the adjacent, sorry, the eight adjacent pixels. What it means here, you can just check it out from here. That is from this figure. Yeah. Now, if we are considering this one, then the one is right of this one, that is one, and one the same pixel is at the bottom of this particular pixel. There are two. So there are two pixels are very near to or adjacent to these particular pixels, and with respect to this, if we are, and there are two adjacent pixels are there, and if we are considering the third one, this one is three adjacent ones are there, that is a 1, 2, and 3. We can write it as a 3, and yes, there is only one adjacent uh, of this particular one. So what is the total of all these adjacent? There is a 2, 2, 4, 4, 5, 6, 7, 8. So there are eight adjacent. So hopefully you are able to get my point. And this one is a M adjacent. There is a there is a when all are connected with each other in a loop, and the another one is a two region. Yes, in this there are two different regions are connecting with each other that are eight adjacent. We are more have to concentrate on these two adjacent values, that is a 4 and 8, and the another one is a mixed adjacent, and in which two pixels P and Q with the values from V are M adjacent. Now it is very clear from this figure, that is a figure C, and let us there is a next another important operations which can be applied on the digital image, that is arithmetic operations. We can do the summation of two images, we can do the subtracting of two images, multiplication, as well as can also apply the linear operations. We can check it out whether the output of a particular image or a given image is a linear or non-linear, and we can do it with the help of a linear operator. And if the result of this equation is equal to this, then we can say it as a linear. Otherwise, it is a non-linear operation. There is a or a digital operation, digital image operation, and this is an example of let us. Okay, I will explain this image in uh, a next lecture, because it is very concerned with the averaging as well as the smoothing. So, but in this case, there are they have averaged the pixels with the help of there is a 5, 10, 20, 50, and the 100 noisy images that we will cover in details in the next lecture. And beforehand to that, we have to do the understand the arithmetic operation. Yeah. Okay, here you can just check it out the arithmetic operation in which the two images, that is image 1 and this one is image 2, and the third one is representing the difference between these two images, that is A minus B, which is equal to this one, where the black is representing the negative, zero, when we get the 0, there is for example there is a 1 minus 1, then we are getting the 0, and the gray or a bright portion is actually representing the change between these two images. So there is a difference operation, and the output we have got the 8-bit. Not oh yeah, we got the 8-bit image, but yes, you can also reduce it up to the 0 and 1. There is a 2-bit image, and so that you will get the better clarity for which one is a change area and which one is a no change area. And again, this is an angiography image in this. When these two images, that is a figure 1 and figure 2, and both these images are subtracted with each other, then we will get the difference image. That is a figure C. And in a figure 4, we have enhanced the difference image. And in upcoming chapters, we are going to do these arithmetic operations, and we will study about the different enhancement methods involved in the digital image process. And this is some example of there is a scanning electron, there is a microscopic image of a tungsten filament, which is multiplied with the there is a figure A is multiplied with the figure figure B, and then we will get the figure 3. There is an example of a product, and yeah, that is okay. And hopefully, you will getting this figure. This is a figure of the teeth. Some infections are there, and there is actually a there is a region of interest which is highlighted by these two blocks. There is a white, and please note that if we have to check the infection at this particular area, we have to ended our operation with this. That is an ended. There is a little bit of logical operation is there, and here it when the one is there, or you can use the if else condition. If the one is there, then it will show the image A. If the black is there, then it will not show the image. So this is your output that is represented by C. Uh, C, and if the one is there, then it will showing the image. If it is a zero in figure B, then it is representing the black. So where ROI is a region of interest mark, so it is called as a region of interest, and so that we can get the valuable information instead of the other irrelevant information. And yes, please note that we can also apply the sets and logical operations on our digital images, and we all are familiar with these sets and set operations, and in which there is a union and intersection is there. And we all are also familiar with this. There is a logical operation. There is a not and or and not and XOR. And these are the important functions because we are using very frequently. These all are in these all operations. And here the note is there in which the black is converted into the white and the white is converted into the black, and another one and is representing the where the both white are occur at this particular location. We will get the this output, and this is again very clear to you. Or and this is the and not operation. They have performed two operations simultaneously, and there is a XOR operation. So when in a XOR operations, when the 1 0 is there, you are getting the one. When the both inputs are similar, then you will get the zero value. Now, the another operations you can perform over the digital image, that is a geometric transformation, and this involves just a rotation. There is a translation. There is a little bit or rotating vertically, or there is a horizontally with the help of these matrices and or equation. You will get the this type of output that is referred to as a geometric transformation. And there are a lot of applications of a geometric. Then I will explain you in with the help of examples. Just you have to understand the what are the geometric transformations, and what are the sets operations, what are the logical operations, what is the subtraction, there is a addition. There are a lot of operations we can apply over it, and we have already done this point. Okay. Okay. Yes. There is a one again. And this is concerned with the there is a nearest neighbor, and the second there is a first. Okay. There is a first figure, and the figure C is concerned with the bilinear. There is a bilinear, and the C1 is a bicubic. Yeah, this one is a bicubic equation. So in this, we have rotated all the figures by minus 21 degrees. And but we have used different interpolation methods in a figure A, that is we have used a nearest neighbor. In a figure B, we have used bilinear, and in a figure C, we have used bicubic. And here you can see that in a figure A, when the nearest neighbor interpolation is there, there are only two values are existing. Please note that this is a highlight portion and which is represented by this following figure, and in which only two values are existing, that is 0 and 1. So that is either 255 or 0. And in case of bilinear, if we are applying the bilinear interpolation, it will give the there is a four values, that is a 1, 2, 3, and 4. And please note that the white is represented by 255 and the 0 is represented by 0. And in the values in between, that is representing the gray level. And in a last figure, that is a C, in which there is a more than four values are there. That is a one value, two, three, four, and 5. So the values are increasing. So this and as you can see that the in a previous we have observed that here there is a bicubic is more uh, gives the better results as compared to the interpol. There is a nearest neighbor interpolation and the bilinear interpolation. And similar in this image, we have just go through the highlighted text. There is a highlighted area of that particular T, in which we can see that there is a more number of gray levels are existing in a bicubic method. So that's why it will give the better result as compared to the another. And yes, there is a vector forming. There is a vector forming a vector is actually concerned with the there is a when we are working on color images, and the color images consist of the three bands. There is a red, green, and blue, and that forms a matrix. And in the previous slide, till this slide, we are just talking about the only one image. But yes, here you can see that there are three images are there because with the different color bands have been added to this one, and that we will do a little bit later. What is a spatial domain and that how we can transform, that we will do in detail. And yes, if there is any question related to this, and you can please ask me. And also note that this is again very a very brief introduction to what's the different operations of the digital image fundamental, and we will do in details in the upcoming lectures. So if there is still, if you have any questions regarding this particular chapter, that is chapter 2, then you can please ask me, or rest can mark their attendance. Uh, Yes, please. If you have any question, please write it on our chat box, or you can ask me. Otherwise, you can mark your attendance and just activating the link.